Section 8.3, Geometrically Defined Vectors and Applications. So in this section, we are going to look at vectors more along the lines from a geometric perspective, and in the next section, we'll look at vectors from an algebraic perspective. So first off, let's review what a vector is. Quantities that involve magnitudes such as temperature, speed, and time can be represented by real numbers called scalars. Okay, so think about temperatures. Okay, so like right now, it might be, I don't know, 75 degrees outside. Okay, it is a number. Okay, when you drive a car, okay, and you realize maybe, oh, I'm going too fast, and you look at your speedometer. Oh, I'm going 80 miles an hour. Okay, that's a number. Okay, time. What time is it? Oh, it's 1:30. That's a number. Okay. On the other hand, if you talk about a vector quantity, vector quantities involve both magnitude, which is just the number part, and direction. Okay, so that's the difference. If you're talking about a scalar quantity, it is just a magnitude. Okay, so it's just a number. But on the other hand, a vector, it has not only a number part or a magnitude, but it also has a direction. So typical vector quantities are velocity, acceleration, and force. All right, so I always talk about this, okay? You need to understand, especially for calculus, the difference between speed and velocity and acceleration, okay? So let me take a minute to talk about that. Like I said already, speed is just a magnitude. It's a scalar quantity. It's just a number. Like I said, when you look at your speedometer, you might be going 80 miles per hour. However, if you are talking about your velocity, that's different because it incorporates the direction. So velocity is speed and direction. Okay, so maybe you're going 80 miles per hour in the north direction. Okay, acceleration is the same thing. Basically, what acceleration is, it's how your speed is changing over time. Are you speeding up or slowing down? It's going to have it's going to have a number associated with it. You might be slowing down at a rate of 5 miles an hour, but of course, since it's a vector quantity, it's going to have a direction associated with it. Okay, so this is what you need to take away from this definition part. A scalar is just a real number. It's a magnitude. If we're talking about magnitude, that's a number. The difference between a scalar and a vector is that a vector is not only a magnitude, but it has a direction incorporated with it. Okay, so moving on to the third bullet point here, it says it is customary to represent a vector using an arrow. The length of the arrow represents the magnitude of the vector, and the arrowhead indicates the direction of the vector. A vector is notated in print with either boldface type, okay, so it might be, if you're reading this piece of paper or in your book or on MyLab Math, you might see a vector in this format. So this would be vector V. It's just the letter and it's been bolded. You can either use a single lowercase letter or you can use two uppercase letters. They would all be bolded to designate your vector. Okay, it's also appropriate to use the same thing, so a lowercase letter or two uppercase letters, not bolded, but in that case, if they're not bolded, then you have to have an arrow over the letters. Okay, so the starting point of a vector is called its initial point, and the ending point is called its terminal point. When two letters name a vector, the first indicates the initial point, and the second indicates the terminal point. Okay, so I'm going to go down here, okay, below these definitions, there's a little grid for me to draw on, okay. One thing to notice, when you're dealing with vectors, yes, they're arrows and you can graph them. You don't always have to have them in the XY plane. Okay, you could just put them on a grid like this, okay, but there are situations where you need to put them in like the XY plane, but you don't always have to. Okay, so down here, I'm going to try to illustrate what I'm talking about in these definitions. Okay, so let me draw something out. We were talking about the vector v or the vector OP. Okay, so it's nothing more than an arrow. Okay, so I'm going to start my vector somewhere, and it's going to have a length and it's going to have a direction. Okay, so say I end up right here. Okay, so this would be my vector, and it's an arrow, like I said. So this would be the initial point, and then right here where we end up, so basically where the arrowhead is, I'm going to put another dot. This is going to be the terminal point. Okay, the length of this vector is referred to as its magnitude. Okay, it obviously has a direction. It is pointing in a specific direction. As far as naming this vector goes, we could call this vector v, okay, or we could call it vector OP. If that's the case where we name it with 2 letters, the initial point would be point O and this terminal point would be point P. Okay, so that is basically what I have already discussed. Okay, so let's go back up here. So we are now right here. The symbol, it looks like absolute value of V. That's what it looks like, but it's not absolute value. It looks like the absolute value symbols though. But if you see that, that represents the magnitude of vector V. Okay, so again, what the magnitude is, if you see this, okay, this is going to be just a number. It is the length of vector V. Okay, and we will eventually talk about how to compute that. Okay, but that's what that symbolism means. Okay, as far as equal vectors, you can have 2 vectors v and w be equal to each other. So that's just written as vector v is equal to vector w. All that means is if they're equal, if they have the same magnitude and the same direction. So equal vectors have the same magnitude and the same direction. So one thing you should notice from this definition, they need not coincide. Okay, you don't have to be talking about the same exact vector. If I go down here and I try to draw a vector that is equal to this vector, I'll put it in a different color, but all it has to do is point in the same direction and have the same length. Okay, so I'm going to look at this since I have a grid on here. I'm going to count. How do I go from the initial point to the terminal point? Okay, well, if I start at O, I'm going to go to the right 1, 2, 3, 4, 5, 6 places to the right. So 6 places to the right. And then I would go up 1, 2, 3, 4, 5, 6, 7. Okay, so if I just repeat that somewhere else in my grid, okay, so for example, I will draw this next vector in red. Okay, so let me say I'll come down here. Okay, here will be my initial point. Okay, I am going to go 6 to the right, 1, 2, 3, 4, 5, 6, and then 7 up, 1, 2, 3, 4, 5, 6, 7. So this will be my terminal point, and I need this vector to go in the same direction. Okay, so this might be vector W. Okay, and vector v and vector w are considered to be equal because they have the same length. I made sure of that by going 6 to the right, 6 units to the right and 7 units up in both situations, and they're pointed in the same direction. Okay, so that's what equal vectors, that's what that means. Okay, so I'll even put right here, vector v as I drew it is equal to vector w. Okay. What else do we have on here? So next bullet point, there's something called the 0 vector. Okay, the vector v whose magnitude is 0 is called the 0 vector, and this is how you indicate it. Okay, and this is important. The 0 has to be bolded. If the 0 is bolded, or if it has an arrow on top of it like this, okay, we could also notate it like this, 0 with an arrowhead. That is the 0 vector. It has 0 magnitude. It has no length. Okay, so it basically does not really exist. You can't physically draw it, is what I mean. So it has no length. It also has no direction. Okay, so the zero vector is a thing. It is a vector quantity. So you need to always pay attention if you see zero in this section or the next. If you're talking about vectors, am I dealing with zero, the scalar, meaning just the number, or am I dealing with zero, the vector? Okay, so you've got to pay attention to that. All right, last thing on this page, it says if v is a vector, then negative v is the vector that has the same magnitude as vector v, but whose direction is opposite to v. Okay, so if you see this, any kind of vector, and like it says here, vector v, and then you see negative v, okay, this is called the opposite vector. Okay, so basically it's going to have the same size, but it's going to have the opposite direction. Okay, so let me write that down. Okay, so it's going to have the same size or length or magnitude, same length, but opposite direction. All right, so I am going to draw negative v over here. Okay, it's equivalent to negative w. Okay, so here we go. I will put this one in blue. Okay, so I need to start somewhere. Okay, so I'll just pick a point. It doesn't matter where because I'm in just a generic grid system here. So I'll start right here. This will be, you know, kind of, well, the first point I put down. And I need this thing to have the same magnitude or length. So to achieve that, I have to go 6 units to the right. So 1, 2, 3, 4, 5, 6. And I need to go 7 up. So that will bring me here. Okay, so these are the 2 points I need to connect with my line. Okay, so that accomplishes the same length as vector v or vector w, but to get the opposite vector, I need to change the direction. So instead of going this way, that's not what I'm going to do. The arrowhead is going to point in the opposite direction. So it would be down here. Okay, so essentially you would be switching the initial point and the terminal point. Okay, so this would be the initial point right here, and this would be the terminal point. Okay, all right, so let me talk really quick about naming this. Okay, so like I said, this is negative v. Okay, it's the opposite vector from v. It has the same size, but it goes in the other direction. If I were naming this thing with 2 capital letters, okay, so look at vector v, the one in green. So we had the O as the initial point, and we had the terminal point as labeled as point P, okay? I would leave these 2 points where they are, okay? And the way you would notate this, since this is an opposite vector, okay, what did we say earlier? Okay, we said right here, when 2 letters name a vector, the first point is going to indicate the initial point, and the second indicates the terminal point. Okay, so you would name this blue vector, the initial point would have to come first, so that would be P, and then O is the terminal point. Okay, so this blue vector is PO. Okay, that is not the same thing as vector OP. Okay, like I said, if you have vector OP, that's telling you that the initial point is O and the terminal point is P. By putting vector PO, that switches the initial and terminal points. So here, this is the blue vector. Your initial point is P and your terminal point is O. Okay, so this is just some of the terminology associated with vectors.